I'm Mr. McBrien. This is TJ20. It's about time. Okay, our quote for the day I could have chosen from a lot, actually. People think about time a great deal, it seems. Anyway, the tick said the fourth dimension is just one big crazy do not enter clambake jungle of weirdity. And we're going in. Alright, so the references for today, the Arduino playground has some interesting code. It'd be a good idea for you to wander around in there at some point and just see what's there, but for today we're targeting what we're looking at. And the Arduino classroom has, chapter 9 is dedicated to time. So these should have a lot of the clues you need to do the activities for today. Yesterday we talked about inputs. Today we're going to talk about elapsed time, real time, and we're going to briefly talk about outputs to screens. Alright, so first let's talk about elapsed time. When you think about it, there's no such thing really as zero time. We can argue about when the universe began, and we can get into some very philosophical things, and this is why there's so many good quotes around time. But like us, the Arduino really has no ability to know exactly what the time is. Instead, it has an internal clock that can measure the delay. And we can use this then to calculate elapsed time. So all time though is measured versus a reference, and the challenge is understanding what to use as zero, what to consider to be when time began. So do some research. What is the real reference for our clocks? Have a look, and if you want to drive yourself crazy, you can start to think about what real meaning that has in the context of Einstein. Alright, maybe you went off and did some reading. Hopefully you're still here. We can talk about our first activity in establishing zero time. You can use your button on your boards or your jumpers to set zero time, and think about what code you would be required in order to do this. And after that point, I want your sketch to print out a count of seconds to the serial monitor. Essentially, you're going to press a button on the Arduino, and the Arduino is going to, from there, start counting. Okay, so hopefully your sketch is up and running. It wasn't a very complicated one. Now let's talk about time again in terms of what we do with time in our inventions. Lots of device actions work based on elapsed or real time. We can probably think of a lot of examples of these that are explicit about using time, for example, stopwatches and things like this, but there are lots of other ones that you might not normally think about. For example, the heating function on your dishwasher might run for 30 minutes to dry the dishes. Things like this. And beneath the surface, there are even more time-based delays where loops will occur and monitoring actions will occur at given intervals. And this saves computer processing time and power in some cases and things like this. They're extremely common in various devices. Now, what we can do is, we're not going to build any elaborate devices today, but we can trigger activities based on delays the same way they do in those inventions. And so what I'd like you to do is create with your second activity a clock that tracks real time. So what we can do is just have the user do the button push, and this time, instead of counting seconds, we can count hours and minutes. Now let's make something practical this time. So let's design and build a system that after the user has set the real time at, say, 12 o'clock by pressing the button, from there a green LED lights at 12:07, a yellow LED lights at 1:13, and then a red LED lights at 1:19. See if you can figure out what this invention is intended to do. At any rate, go ahead and implement this as activity 2 in the time-based work. And I'd invite you to think about how you might enhance this invention. I have some of my own ideas. There are lots of things that you can do here, of course. Okay, displays to a screen. We haven't really talked about pushing out to, for example, an LED screen. But it's really not a terribly complicated task. And so it would seem logical, now that we have our timer device, why not make a countdown clock? So the Arduino supports various screens. As an extension, if you get the time afterwards, we'll get you a screen and you can put it onto your clock so it counts down from 74 minutes to 0 every day at 12:07. We can talk about maybe we'll put a couple of other doomsday clocks around or something like this if this turns out to be an interesting activity. All right. Notice that what we had previously was a real-time clock, but the onus was on the user to set the clock. There are additional add-ons for the Arduino library that can enhance its ability to deal with time in a more specialized way. So the real-time library is in the playground, to which I alluded at the beginning. And you can go ahead and download that material to your computer, not a problem there. The real-time library is pretty interesting. There's no need for more hardware, so we don't need any shields or anything like that. But once it's in place, the Arduino code will support a 24-hour clock. It'll be able to report day, date, month, and year, and has a little bit more elaborate functions for calculating elapsed time. But also, we can then access a real-time clock as well. So here's some of the code for the retrieving information about day, date, month, etc. If we want to, though, avoid having that step of the user pushing a button to set the time, well, the Arduino has the capacity, once the time library is in place, has the ability to access time from various external sources. So it can access the computer time from the serial port. It can access network time from the Ethernet shield if it has one. Or if you've got a GPS shield, the GPS system also reports time. Again, all of these approaches require the Arduino time library, but if your Arduino is connected up either to a computer, the internet, or GPS, it can get a very accurate time automatically through your code. So, if you have the time and you want another extension, go ahead and download the Arduino time library. Write a sketch that retrieves the time from the serial port, so you won't need a shield to do this. And then write a sketch that delays for 24 hours. So it counts away the number of seconds. What would that be? 24 times 3600. You know what? I'm not going to do that math for you. You can work it out. And then at the end of 24 hours, go ahead and retrieve the time again. And then just simply push the comparison of the time elapsed to the serial monitor so that you can see what's going on there. Notice that the output to the serial monitor, if you compare, should indicate how accurate your Arduino time measurements are. Okay, so to summarize, elapsed time is an important value to many inventions. The basic Arduino tools can work with time fairly effectively using the delay function. The Arduino time library, though, has tools to retrieve real time and also to understand 24-hour clock, days and months, etc. For your homework, please go ahead and update your activity for code for today. Thanks very much, and have a great day.